So, when we're studying acid-base relationships, we have to concern ourselves with what exactly is an acid. Well, we know that they taste sour, and they tend to dissolve metals, and they come out to be, well, they produce a red color when you put it through a litmus paper test. And there are a few notable examples when studying acids. For one, we have hydrochloric acid. Not only is it an active ingredient in our stomach, which helps break down our meals, but it's also been known to help clean metals. Did you know that you can pour Coke on a rusted metal piece and it'll come out clean? It's just a bottle of Coke and a little bit of elbow grease. It's also been used as food prep, but I'm not too familiar with that, so we'll pass on that. On top of that, there are other notable examples such as sulfuric acid and nitric acid. These two play a role in agriculture by consisting of fertilizers. And what if I told you that the use of fertilizers could take a real dark turn, as they make great explosives. On top of that, if you have an abundance of sulfuric acid, did you know that most car batteries tend to rely on them? Now, with sulfuric acid and nitric acid covered, there is one more notable example, and that example is acetic acid. This one's like the weakest of the acids I mentioned earlier, as it's an active ingredient in vinegar. And it also plays a role in alcohol when it comes to the process of creating wine. Now, what happens if wine was to be stored improperly? It turns out vinegar starts to build up and the wine ends up tasting like salad dressing, which, if you think about it, it's the last thing you want in your wine cellar. Now, acetic acids also contain a functional group known as carboxylic acids. Carboxylic acids are abundant in living organisms, and they're also abundant in citric acid, which is found in fruits that tend to taste sour, and malic acid, which is found in fruits such as apples and fruits that don't really taste that sour. Now that we've already covered the nature of acids, what about the nature of bases? Let's see here. Okay, so currently we understand that acids are basically the antithesis. The bases serve as the antithesis of acids. According to litmus paper scale, most basic solutions, or all basic solutions, result in a blue color, and they also leave a bitter taste in our mouth. Now, generally speaking, most humans do not they don't fancy foods that are on the basic side. And historically speaking, that is because alkaloids have long been associated with poisons derived from plants. In fact, did you know that Socrates was killed by an alkaloid-based poison? And the reason why for his death was for quote-unquote corrupting the youth, but that's for another topic. On top of not being suitable for human consumption, or at least it being an acquired taste, they tend to make up the majority of cleaning products, ranging from bleach, ammonia, and the like of it, as well as being really slippery when interacting with the oils in our skins, and that tends to be all the soaps that we know of. Now, in your chemistry course, there are going to be two basic solutions, or two basic compounds you're going to work with. That's potassium hydroxide and sodium hydroxide. And while they are primarily used for cleaning up spills, they also play a pivotal role in our comprehension of acid-base relationships. Well, that's about it. That's a wrap for this video, and this is only a soft beginning to understanding acid-base relationships.